Okay, so the next example, f of x is equal to x times e raised to the x squared minus 3x power. We're trying to find where this is increasing and where it's decreasing. So first thing we want to do is find the critical number. And we do that by setting the derivative equal to 0 and finding where it's undefined. So now we have to look at what rules we need to apply when we look at this derivative. So notice we have x times the function e. So we need to use the product rule there. And then when we take the derivative of e, we're going to need to use our chain rule. So let's just write that out. Derivative of f of x. This is equal to the derivative of the first. So d dx of x times the second, e raised to the x squared minus 3x, plus the first, x, times the derivative, d dx, of the second, e to the x squared minus 3x. So going through and doing that, derivative of x, well, that's just 1, all times the second function, e to the x squared minus 3x, plus x, all times the derivative of this e function. So remember, the derivative, we're going to look at the derivative of the outer. So that's just this e. Remember, the derivative of e is just itself, e of the inner, which is our exponent, x squared minus 3x, times the derivative of the inner. The inner piece is the exponent. So the exponent derivative of x squared is 2x. Need parentheses around this, minus the derivative of 3x, which is minus 3. Okay, so this doesn't look very pretty, but it actually is going to clean up pretty nicely. Notice that we have that e raised to the x squared minus 3x in common in each piece. So I have it here, and I have it here. So I can actually factor that out. So let's pull that e piece out of both of those groupings. And so if we pulled out that e, we're pulling out the e of the x squared minus 3x piece. If I pull that out of this, all you're left with is the 1. So all times the 1. Then we have our plus sign. We pulled it out. We pulled this out, so we have to write what's left. We're left with this x here, and we're left with this parentheses 2x minus 3. So looking at this, we have f prime of x is equal to e to the x squared minus 3x, all times 1 plus, let's distribute this x inside the parentheses. So we have 2x squared minus 3x. We're going to want to find out when this is 0. I would want to see is what's inside that parentheses factorable. So maybe we can do that on the side. So I'm going to rewrite that in descending order of power. So 2x squared minus 3x plus 1. Let's see if that factors. So I'm going to use my AC method. So my A value is 2 times my C value, which is 1. So 2 times 1 is 2. So it multiplies to 2, but would add to give me negative, my B value, negative 3. Well, negative 2 times negative 1 is positive 2, and negative 2 minus 1 is negative 3. So we found those two numbers, negative 2 and negative 1. So we're going to rewrite that middle term with these two numbers. So let's do that. Doing that, we have 2x squared. Rewriting the middle term, it's going to be minus 2x minus 1x. And then a plus 1. Let's factor by grouping. Pull out what we have in common in the first two terms. So a 2x squared and a negative 2x. Those both have a 2x in common. Let's do that. And we pull that out, we're left with a x squared for that first term. Sorry, not an x squared, just a single x. And pulling out a 2x from negative 2x, we're just left with a minus 1. I want what's inside this parentheses, once I factored out of these last two terms, to be the same thing, x minus 1. Right now we have negative x plus 1. So I can manipulate it to look what this x minus 1 by pulling out a negative 1. So let's pull out a negative 1 from these two terms. So pulling a negative 1 out of negative x, that's going to give me a positive x. And pulling a negative 1 out of positive 1 gives me minus 1. So now what's inside the parentheses is the same. We can factor that out, x minus 1. So if we pull out x minus 1 from the first grouping, you're left with this 2x here. And if we pull out a x minus 1 from the second grouping, we're left with a minus 1 there. So it was factorable right here. So let's rewrite this. We're looking at when is our derivative equal to 0. So we're looking at when is e to the x squared minus 3x all times x minus 1 all times 2x minus 1 equal to 0. If you graph your function e, so kind of recall, that's just 2.718 irrational number, so it goes on forever, but let's just say 2.7. And if we raise 2.7 to any number, you're never going to get this to equal 0. And so remember, e kind of looked like this function. It had a horizontal asymptote, but it never crossed the x-axis. And so this piece here, this e to the x squared minus 3x, when we're looking at when is that equal to 0, we don't have to worry about it. We also have to look at when is x minus 1 equal to 0. And when is 2x minus 1 equal to 0. Okay, so we just said that this never happens. But x minus 1 is equal to 0 when x is 1, adding 1 to both sides. And we can see that 2x minus 1 is equal to 0. So let's add 1 to both sides. We get 2x equals 1. Divide both sides by 2, we get x as a half. Okay, so we have two critical values. And we have to also look at when is this undefined, but this is defined everywhere. So we don't have to worry about that. And now we need to put our critical numbers on the number line. So smallest one we had 1/2. Largest number we had was 1. And so that means we have to test 3 different intervals, plug it into our derivative to see is our derivative positive or negative at those numbers. So let's look at x equals 0. That is a number that is smaller than 1/2. And so if you plug in, let's plug in 0 here. Well, e raised to the 0 is 1. That's a positive number. All times, actually, let's plug it into this piece. 0 minus 1, that's a negative number. And 2 times 0 minus 1, that's a negative number. So if I multiply a positive times a negative, that's a positive number, and this is greater than 0. So f prime of 0 is a positive number, which is greater than 0. So it's increasing to the left of 1/2. Let's not look at the middle piece right now because that's a fraction, but let's look at x is bigger than 1. And so choosing a number x is bigger than 1. Bigger than 1, so how about x equals 2? So plugging in 2, we get e raised to the 2 squared, that's 4 minus, it doesn't matter if I get a negative exponent in e, that's going to bring it down to the denominator, but it's still going to remain positive. So when I plug in 2, that first piece is positive. If I plug in 2 to x minus 1, that's positive. And if I plug in, 2, if I plug in 2 to 2x minus 1, that is also positive. So that's going to be greater than 0 there. So that tells me it's increasing on values to the right of 1. So now I just need to worry about a number between 1/2 and 1. So let's just choose that really quick. So x equals, how about 3/4? So let me plug it in here, f prime of 3/4. So if I plug it into the original, the e function, that's positive. Plugging in the derivative, actually. 3/4 minus 1, that's going to be negative. And 3/4 times 2. Well, that's bigger than negative 1. That's 1.5 minus 1, so that's positive. So positive times negative times positive, that's going to be less than 0. Negative number, it's going to be decreasing here. It's almost there. So we're increasing from negative infinity to 1/2. Union, we're also increasing starting at 1 to infinity. And we're decreasing from 1/2 to 1. Those are the x values of the function where they're increasing and decreasing. So let's stop there. So next class, we'll look at, again, looking at where there's maximum and minimum values on our function by looking at where things are increasing and decreasing. So just kind of like we had done earlier today, just giving you a preview, increasing to decreasing, and you can see that there's a max there if it's defined on the function, which 1/2 is, and decreasing to increasing, I know that there's going to be a min there. So we'll look at that next class period.